My last presentation a few months ago was about the Kibini alkaline massif. This time I'm going to talk about its little brother, the Lovozero Massif. It is very close to the Kibini, and it's in the central part of the Kola Peninsula, and next to 19 others. How close is this slide? It shows you that it is just, I can see my presentation slides here, yes. It's just a few kilometers to the east, actually 5 kilometers, and it's slightly smaller. It's only 20 by 30 kilometers. So it's not exactly the same, but it's close. The Lovozero Massif is located between two large lakes. To the left, Lake Umbuzero. To the right, to the east, Lake Lovozero. And in the center, we have Lake Sidozero. So there's a lot of lakes going on between those alkaline massifs. Something about the lakes. Lake Umbuzero is the largest of the three. It's located to the west of the massif and is 422 square kilometers and is relatively deep. The shallowest depth is about 15 meters and the deepest part is 115 meters. So good for taking a swim, a bit cold though. The second largest lake, Lake Lovozero, located to the east, is about 200 square kilometers and it's shallower than its brother. It's only 5.7 meters on average and a maximum of 35 meters. The third and smallest lake, Lake Sidozero, which is in the center of the massif, is only 20 square kilometers, 8 by 2.5 kilometers. Something about the geology. The Lovozero Massif is an intrusion of rocks similar to the Kibini, but they slightly differ in their composition and also on accessory minerals, as well as in the directional texture of the rocks. It's an intrusion with an age of 388 to 347 million years and is composed of several zones, well, actually 2 zones and some veins. The outer zone, the first outer zone, is called light blue on this picture, is a differentiated complex and is composed of layered earthite, lugifrite, and foyite rocks. The second ring, which is not actually a ring, it's a half a horseshoe, orange one, is the eudialyte complex, and it's completely made up of eudialyte lugifrite, and they are all nepheline cyanides, but with a specific composition. The third party is actually the green stuff you see here, and that's our poikilolytic cyanides. I will tell you more in a few minutes about these things. First of all, how did it came to be? This is a picture of from the collapse of the Lovozero caldera and the subsequent volcanic activity. It was deployed with the oldest one on the left, top left, and the youngest one on the bottom right. It started with the collapse of the Lovozero caldera on frame A, and it's actually originated within the late Archean tonalite, strontiumite, ground diorite complex. The second volcanic activity began 427 million years ago, and it started with intrusion, a subalkaline ultrabasic melt. It's the purple to the right in picture B, and it formed the Kurga intrusion. So actually not the Lovozero intrusion, because the Kurga is situated to the east of the Lovozero complex. It's a smaller intrusion, but it was formed, well, very long time ago. In the third picture, you see an alkaline ultrabasic melts were introduced, and they formed this purple intrusions of olivine pyroxenite, melitolite, and olivine meltite bodies, but they only predominantly originate in the northeastern part of the massif. After that, the formation of the poikilotic sodalite cyanide complex was formed. It's the yellow stuff. And actually, those formed throughout the Lovozero Massif. After that, a formation of low-porite bearing lutherite, foyite, and ertite layers came into place. It's the largest volcanic activity that took place. And you can see that the poikilotic well, name escapes me, but just actually made lenses now in the low-porite bearing lutherite, foyite, and ertite layers. This is the layered complex zone. After that, at 347 million years ago, the orange came into place, the orange volcanic activity, and it's the forming of the ureolite lutherite. So you see, it's a subsequently forming volcanic eruptions with different melts that came to the surface during, well, 80 million years time frame. The differentiated or layered complex is gently pitching, and it's rapidly alternating horizons of lutherite, foyite, and ertite. And it is depicted here in this picture on the right. And it's repetitive, so it always has lutherite, foyite, and isolite, ertite, and then again lutherite, foyite, and isolite. So it's a series of volcanic eruptions which deposited these layers, but in a gently pitching and rapidly alternating horizon. The ureolite complex was a big event, and it actually did overlay the differentiated complex, and it consists of ureolite lutherite and ureolite lutherite porphyre. This is a picture which shows both complexes. This is Mount Sengishore. It's one of the mountains which I will not be discussing, but it was here you can see that the different complexes above each other. So the oldest ones are at the bottom, and the newest ones are on top. Talking about localities, I only have mineral specimens from 7 localities within the Lovozero Massif. And that's from Aluaev Mountain, Lovozero Mine, which is actually in Aluaev Mountain, Karnasut Mountain, which is 3, and the mine, which it operates. Then Kedik Mountain, which is actually connected via to Karnasut Mountain via the mine. It's very funny. Then I go to Selsrut Mountain, which also is known as Flora Mountain, and Sidozero Lake. Well, not actually the lake, but the river affluences, sorry, which actually donate their stuff in the river, in the lake, but it cuts through rocks. And last but not least, Lepkinel Mountain. I only have 1 specimen from there, but I will also show it to you. Up to date, there are 408 IMA registered valid minerals, 109 type locality minerals, and 2 first recorded locality minerals. So again, a lot of minerals in this alkaline massif. The first locality is the Aluaev Mountain. Like in the Kabini, the mountains are not very high. They range, well, maximum 1100 meters. So they are all flat topped and have steep valleys beneath them. Aluaev is situated in the northwestern part of the Lovozero Massif, and is actually the locality which produced the most minerals. And it's approximately 8 kilometers south of a small mining town called Revda. I have from the mountain 7 minerals, and quite a lot of them are type locality minerals. First one is the aluaevite. It's a type locality tectosilicate. First of all, I have to explain my picture because I have a crystallography picture here. and to the left, a name given picture to the far left, and a block to the upper right, where it says which group of minerals it contains to, and a color which indicates the rarity of the mineral. An orange stands for rare. It's a tectosilicate from the concrete group. It's colorless and it shows nice prismatic crystals. Bear in mind we're micromounters, so this field of view is only 4 millimeters. So the crystals are very small. The second mineral, also type locality mineral, is another silicate, but this time a cytosilicate from the ureolite group. It is not very obvious in the picture. I should take it back to the picture, but there's 3 loose pieces of pale lilac cancrystalite. Cancrystalite was named late in 1999 after the relationship with cancrinite, which it has no resemblance bearing, but with a relatively high ratio of silicon to aluminium in its composition. The third mineral is dorfmanite. Dorfmanite is again a rare mineral. It's only not a silicate, but a phosphate, a sodium phosphate. These are very small pieces of crystal aggregates. Again, not very obvious in the picture. I'll have to retake those again. And it is stored in a capsule because it is prone to being dehydrated or hydrated by air. This dorfmanite was named in honor of Moisei Dorfman, who was a Russian mineralogist at the Freshman Mineralogical Museum. And he was investigator of Kabini minerals, and he was the one who first reported a sodium phosphate in 1963. Next one is another type locality mineral, this time a sulfate. It's called cogarcoite. There is a trend going. If I go back one more, no, you see this is a sodium phosphate. This is a sodium sulfate. It is light blue and it's in a solid state here in matrix. It was named in honor of Leah Koharko, which is still a Russian geochemist at the Department of Earth Sciences. She was born in 1936, so she's pretty old, and she discovered this mineral. Manganotighite, another type of mineral, this time sulfate-bearing carbonate. Again, it's very difficult to see, but this is the mineral. It's pale pink, and it is in a solid state, and it's in a matrix with agerine crystals. And the matrix in this case is usingite. The name is funny because it is named after the Greek tyche, which means luck or chance for its rarity. Again, this time it is a red thing, which means it's very rare. They found only 1 in 10 crystals in 5,000 pieces, so very rare. Another type locality mineral. The previous one was a sodium manganese sulfate bearing carbonate. This is a sodium manganese phosphate bearing carbonate. Again, it is pink and it forms blocky crystals, Sidorenko. And it was in honor of Alexander Sidorenko, who was, well, you look at that, a Russian geologist and founder of the Kola branch of the Russian Academy of Sciences. Okay, this one is not a type locality mineral. It's ticinolite. It's a cyclosilicate with a complex formula, and it's a member of the Lovozero group. It forms orange-yellow small crystals with agerine and nitrolite. The name of the ticinolite is because of its chemical composition. It stands for titanium, Ti, silicon, Si, and sodium, Na. So that's funny. The Lovozero mine, which actually is part of the Aluaif mountain. And it was a large underground mining operation, which predominantly exploited a number of ultra-aquatic pegmatites, like the Skatoka pegmatite, located in the western part, and the Shomiaoki Tofu pegmatite in the northern part. But due to an occurrence of a catastrophic rock burst in 1998, the mine was closed and subsequently flooded. There is still a lot of minerals to be found in the heaps, in the dumps. Again, the minerals I have from that locality. And we start with purpleite, which is a rare sorosilicate from the wilderite group. It is orange-yellow and solid in this piece in matrix. I don't have a clue what the dark brown matrix is, but maybe somebody can tell me, or I can ask someone who knows. And it's named after the Bopala alkaline massif in the Buryatia Republic in Russia. This one is purple, and it means it's endemic. Caryochrogite is a type locality mineral for this locality. It is at the moment shared under the unclassified silicates. It is not very aesthetic. It's solid. It's brown. Normally you wouldn't give it a second look. It's named for the Greek karyon and chrosis, which means hazelnut color. Well, you can understand why. Next one is alpidite. Alpidite is another silicate, an inosilicate, and it forms very nice colorless prismatic crystals. Again, this is on caryochrogite, the endemic mineral. The name comes from the Greek alpides, which stands for hope, representing the hope that other interesting minerals will be found at the type locality, which is not the Lovozero Massif, but Narsarsuaq pegmatite in Greenland. And a lot of interesting minerals came from there, so that's good. Gaydonite. Gaydonite is, it says colors, it's not true, it's a bit milky white in this picture, with a colorless hue. And it's an inner silicate from the Gaydonite group, and it's named in honor of Dr. Gabriel Donnet. It's a American-Canadian chemist, mineralogist, and crystallographer, and she worked for 20 years at the Geophysical Laboratory, Carnegie Institution of Washington, and later at the McGill University in Montreal. Calamite, another rare, very rare silicate, a phyllosilicate this time. Again, only a solid piece. Crystals are very hard to get, and I probably couldn't afford those. It's white, and it's named for the Kalem region in Lake Chad in Chad. Korobitsinite, another type locality mineral. It's a cyclosilicate from the Labunzovite supergroup. It's colorless to white, and all those prismatic acicular crystals here are korobitsinite. There's also aegirine and albite in this picture. This one was named not after a mineralogist, but an amateur mineralogist, Mikhail Korobitsin. He was an avid mineral collector and made significant contributions to mineralogy applications of the Lovozero alkaline complex. So also we can also do our best and get a mineral named after us if we just try. Lamprophilite. It's an uncommon sorosilicate, but it's more common than the rest I showed you. It belongs to the siderosierite supergroup. It's brown-yellow. It forms nice elongated prismatic crystals, this time with aegirine and albite. The name stands for the Greek lampros phulon, which means shining leaf, for its clusters, lustrous and cleavage. Next one is lifinskite. It's a very rare type locality mineral, a cyclosilicate from the Lovozerite group. It's red-brown, again, a solid piece. Maybe here parts of crystal, I'm not sure. And this one was named after Galia Lichinskaya, who was also a geologist and geochemist at the Moscow State University. Mosandrite, a sorosilicate from the siderite supergroup in the circle. It's brown yellow, and it is presented as small crystals with quartz on matrix. And this one is from the name is from Carl Gustav Moisander, who was a Swedish chemist and mineralogist, and he had discovered and described the element lanthanum in 1839. The CE suffix was introduced by the IMA in 2016. Well, common mineral, naturalite, is a textilite of the zeolite group. It's colorless and it forms from the Lovozero location of a massive blocky crystals, colorless, not very large, and mostly it is just a solid matrix where it forms. Paracaldicite, another sorosilicate. It's well, it says here white, but I think it's colorless. So I mixed up the colors of you in my presentation. I see now. It shows some blocky, incomplete crystals on matrix, and it was named after Mstislav Kaldish, who was a Russian mathematician, and he was the father of the first Earth space program from Russia, and he developed the satellite Sputnik. Shomiokite. Why? Also a type locality mineral. This one is a carbonate. And this one was named for the type locality, the Shomikitovu pegmatite in the mine. Terskite, an inosilicate. It is difficult to see, but you can see a hue of lilac here. It is not crystalline. It's solid on udilite matrix. So it comes from the upper levels of the mine. And it was named after the Tersky coast of the White Sea. Tersk is namely an old name for the Kola Peninsula. Usingite. That's the pink stuff over here. And the dark green / black is the azurine again. You find it everywhere. And it's a solid piece of usingite, and it was named in honor of Dr. Niels Viggo Using, who was a professor of mineralogy at the University of Copenhagen. Next locality, the Carnassut Mountain, is also a very rich locality in the northern part of the Lovozero Massif. 186 developed minerals were discovered there, and 46 type locality minerals. The name Carnassut can reflect on the mountain as well as the mine, and it's the second richest locality next to Aluaev Mountain. There are several well-known sublocalities, pegmatites, such as the Jubilainaya, the Naturalite stock, and the second eastern stream. And it can be nice weather there or really bad. I have a lot of minerals from this locality. And the mine, they mine loparite there for the rare earth elements. First mineral from there is bellovite, which is a phosphate from the apatite supergroup. We see some incomplete honey yellow crystals in matrix. And again, named after the Russian Nikolai Belov, former head of crystallography and crystal chemistry at the Moscow Lomonosov State University. Vernacite. Vernacite is an oxide. It's black. It forms platy black crystals, and is named after the type locality Burness in Scotland. Another type locality mineral, bornemanite. It's a soil silicate from the siderite supergroup. In this case, it's the yellow-brown stuff over here. The dark brown stuff is Loman. And again, named in honor of a Russian mineralogist. She specialized in Kabini and Lovozero minerals. And her name was Irina Bornemann-Starinkevich. Scalovite. Scalovite is an inosilicate, sodium beryllium inosilicate, and the color is colorless, so not very noticeable, and I only have a solid piece of it. But the name is interesting. It was honored to honor Valery Chkalov, who was a Russian aviator and test pilot, and he was the first pilot to make a non-stop flight from Moscow to the US via the North Pole. Gerasimovskite, another oxide. It's a gray. It's depicted here, and again it's solid in a matrix with azurine. And the matrix seems to be usingite by the looks of it. Non-Russian mineralogist Vasily Geramovsky, and he was one of the leading investigators of the Lovozero Massif. Ilmeniochite, Ce, another type locality mineral, another unclassified silicate. They don't know yet in which category it falls. I only have loose pieces in a capsule, so I had to take them out and try to photograph it. There are some yellow loose pieces here which look like crystallized. I'm not too sure about that. And the name was given for the Ilmenioch River on the Kola Peninsula, located near the type locality, the Jubileinaia pegmatite. Names are killing me. Next type of mineral is icronite. It's not a cyclosilicate from the utilite group. It's brown yellow. It is again solid, maybe crystalline. I don't really know. But this mineral was named in honor of the ICRAN Institute. It's the Institute Krystallography Rossiyskoi Akademii Nauk. My Russian is terrible, sorry. Next mineral is another type of mineral, a soil silicate named carnosurtite, Ce. It's honey yellow, it forms platy crystals. I've got the luck to have one here. There are more crystals on the specimen, but I can only photograph one. It was originally called Kojanovite, but they did not give a description, so the IMA did not name this mineral Kojanovite, but instead named it carnosurtite after the type locality of Carnosurt Mountain. Another very rare type locality mineral, Komarovite, again solid, pale pink. It was named in honor of Vladimir Komarov, who was a Soviet test pilot, engineer, and cosmonaut. And he was the 14th person in space and the first cosmonaut to travel twice into space. Unfortunately, he died on re-entry during his second space flight due to a failed parachute. Kyanoxylite, another type locality mineral, a tectosilicate. It is pale blue, so it stands out. And again, it's solid but in matrix. It was named for the Greek kyanos, blue, and reflect the mineral's blue color and the presence of oxalate, C2O4, in its chemistry. Well, here's the lomonosite I promised, lomonosulfide, sorry. Type locality, soil silicate from the siderite supergroup. It's a dark brown stuff we saw earlier, and it was named in honor of Mikhail Lomonosov, a Russian scholar and poet, mineralogist and naturalist in the 18th century. And again, a type of clarity, very rare tectosilicate from the zeolite group. Only this one forms a thin crust on scalovite, and thin white crusts. And the name was given and stands for Dar Lovozera, and it means a gift from Lovozero. Next type locality mineral, the Mangana Nordite, CE. Very rare inosilicate from the Nordite supergroup. It is black, and it is shown here with birnasite and gerasimovskite on matrix. Nordite was given the name for the word of north, of course, because of its northern origin in the Lovozero Massif, and of course mangan for the dominant analog. Mountainite, a rare tectosilicate. It is white, and I think there are some fibrous crystals here, but again, the picture is not great, so I have to retake this again, with a zorite and natrolite on matrix. It's named after a South African professor of geology, Edgar Mountain, who provided the first specimens for investigation. Now, type locality mineral, the nesosilicate natisite, again named after its chemical composition: sodium, natrium, titanium, and silicon. And it's the gray-green stuff here, and it's flanked by all acicular natrolite crystals. Natrophosphate. It's a phosphate, as the name suggests. It's white, and it's crystalline in nature, and it's again on a syncite. Natrosilicate, another type of alkali mineral. It's a phyllosilicate. Colorless, doesn't show very good, except for this one here. It's a partial crystal. Again, it's stored in a medicine pill for safekeeping. Nordite CE is a brown. It's a crystal over here. It says silver, but I think it's a crystal. It's not very fully developed. And again, with azurine and natrosilicate in Ussingite matrix. Another weird one, organovaite, manganese, type locality mineral from the labensite supergroup. It's orange-red. It's again not aesthetic, but it's in a Ussingite matrix again. And this one is another Russian crystallographer, Natalia Organova. Pankvilksite, a phyllosilicate, again a solid piece, and it's named after the Sami words pank for white and vilkis for curly, so curly white. Phocinaite CE. It's a cyclosilicate. It's light brown. It's a very small crystal in Ussingite matrix, and it's illusion of its chemical composition: phosphate, silicate, and natrium. Phocinite. Polylithionite. It's an uncommon mineral, uncommon phyllosilicate from the mica group. It's pale pink, and it comes from the word many and its high lithium content. Rayite, and you pronounce it rayite because it was named after the papyrus boat Ra, which Thor Heyerdahl sailed in with other friends in 1969 to 1970 to prove that a papyrus boat could sail oceans. It's golden brown, and it's small acicular crystals in quartz matrix. Sideite CE, another type of mineral, inosilicate. It's cream white. It forms radial shaped crystal groups on matrix, and it's named after Lovozero, the lake in the center of the Lovozero complex. Cerandite. Cerandite is an inosilicate. There are very long elongated prismatic crystals here, orange, in Usingite matrix. And the name it's named in honor of Jules Serran, who was a lighthouse keeper on the island of Rauma in the Los archipelago. He was an amateur mineralogist who assisted collecting the mineral. So even lighthouse keepers get the mineral named after them. Lovozerite, another unclassified mineral. It's a type locality mineral. It's brown. It's radiating sprays of acicular crystals in Usingite matrix. And it's named for the Lovozero Lake, the lake to the east of the Lovozero. No, yeah, Lovozero to the east. Yophortierite, another silicate from the polygorskite group. I don't know if you ever seen polygorskite. They form these fluffy groups of crystals, and so there's this one. Only this one's dark brown. It's named in honor of Yves Fortier, who was director of the Geological Survey of Canada, for his many contributions to Canadian geosciences. Zorite, an endemic time locality mineral, member of the zorite group. It's pink, and it's difficult to see, but it's here with manganoneptunite in and on the zorite matrix. So, but there are definitely crystals here. It doesn't show that well on the picture, but under the microscope it looks stunning. The meaning of the name is from the Russian Zoria, which means the rosy radiance of the sky at dawn. Well, the Connors mine operates in both Connors Mountain and in Kediverpak Mountain, and the ore mine is Loparite CE. As an ore for the rare earth elements. Kediverpak Mountain. Again, two different pictures. Very nice autumn, and probably just before winter. Oh. And the pegmatite number 31, also known as the Palitra pegmatite, is the only pegmatite in the Lovozero Massif which was not hydrothermally altered after its formation, which means that a lot of the minerals found here are very unstable in air. I only have one. It's called mangan belyantinite, and it's an oxide, black, forms very small crystals, and is named in honor of Dmitry Belyankin, a Russian mineralogist. Cell sort or flora. Sorry. This is an odd locality within the Lovozero Massif. It is located northeast of Karmasurt on the very edge of the intrusion. Therefore, it is not in the ureolite lugifrite complex, but in a differentiated zone. I have 4 minerals from there. Starting off with calciumurmanite. It's again a silicate, very rare. It's light brown, and it forms crystals with narcissicite on matrix. And it's named after the Murman coast on the northern side of the Kola Peninsula. Kuzmenkoite manganese, another type of locality mineral. It forms yellow, small crystals on naturalite matrix, and is named again after the Russian geochemist Maria Kuzmenko. Murmanite, after the Murman coast, the northern side of the Kola Peninsula, forms brown crystals in Isingite matrix. Sphalerite, well, everybody knows what sphalerite is. Only here we got the the iron variety of it. Marmotite. Well, Lovozero Lake. It's the lake in the center of the massif. Not very large, but it has an effluence, river effluences, which got through pegmatites. And this time it's pegmatite number 58. It's a 1 meter thick pegmatite vein cross-cutting polyclinic nepheline cyanide in the Murray River Valley. And here comes siderite one. It's the type of locality mineral because it was Lovozero Lake. It's a rare straw silicate, orange brown, and it forms crystals with, again, agerine on matrix. The last locality, it's a Lepke Nelm. I don't know what that translates to. It's probably a Sami word. And it's located just southwest of Lake Lovozero, and it hosts the two known pegmatites, number 45 and 47. In this picture, this is the pegmatite number 47. I only have one mineral from there. It's called tiniolite, and it's a phyllosilicate from the mica group. It is very dark brown. It forms platy crystals. Difficult to see in this picture, but you can see some nice polylithionite crystals on a quartz matrix. And is named after the Greek tainia, which means ribbon. Well, to end this presentation, I have some interesting reports on Kabini and Lovozero excursions you can look up to. One is from mineralogical excursions in the Kabini and Lovozero mountains from the Russian Academy of Science, and one from Spirifa Minerals. They did an excursion to the Kola Peninsula in August 2009. That's all, folks.
That was very, very good, Frank. Thank you.
A bit quicker than I expected, but
No, that was good. And do we have
I
any
hope
questions?
I can answer any questions because I haven't been there. But
I was just wondering, I missed at the start the timing of the various intrusive
the
events.
volcanic eruptions.
Yeah.
Yeah.
Are they all, like, I got the impression there was a 40 million year period between the first and the last. Is that right? Or are they over a longer time?
80 million.
80 million. Okay. So they're all from the same, probably from the same mantle source.
Yeah, I think it is. Yeah.
Couldn't help noticing.
Oh, yeah,
Yep, go. You first. It's your talk.
Oh, okay. Well, the differentiated complex, you can see that it was steadily and building up in layers. So that gives it away that it was actually from the same mental things.
In terms of the geochemistry, I couldn't help notice there was a lot of phosphates, sulfates, and carbonates. Are they metamorphic influence crystallography, or have those volatiles come up with the intrusive?
They have come up with the magma.
Yeah. Okay. Good. That's where the interesting stuff happens, I guess. Yeah.
Yep.
Yeah. So
there are a lot of interesting minerals.
So not quite a carbonatite, but with a lot of those volatiles in there.
Yeah.
Yeah.
Yeah, you saw carbonates with a phosphate content, carbonates with a sulfate content. So it's really interesting things. Even the oxalate. That's great.
Yeah, that was a weird one. That threw me. Not exactly expected.
No, but it is from there.
Yeah. Also, a couple of phosphates in the silicates as well, too, which was interesting.
Yeah, it's very weird chemistry over there.
Yes. Do you? I mean, obviously, I get the impression that most of the mining was for the rare earths.
Yeah.
Yeah.
Yeah, in the Cabini it was apatite, and
Yes.
in the Lovozero it is the rare earths.
Do they know why that particular body has more rare earths than or what's concentrated with those rare earths?
I have no clue whatsoever.
No.
I will look into that, but I have no clue.
I don't know either. So yeah.
But they have pretty large loperite zones in both the differentiated complex as the ureolite lagifrite complex.
Yeah.
So
I get
so it's
the
abundant there.
I get the impression that the chemistry of those rare earths can be quite weird.
Yeah, I think you're right.
I don't have a question. I just have a little comment that I really appreciate the time you spent on the source of the names for all of these.
Yes.
And I empathize very heavily with your Russian pronunciations because those are tough.
Okay, thanks.
Frank, the Russian reference that you
Yeah.
listed at the end, is that in English?
Sorry?
Is it in English, the Russian reference?
It is in English, yes. Yes. Yeah, otherwise I wouldn't have shown it to you.
I might get you to just send me the link.
Yeah,
and
I will.
I'll include
Yeah.
it in the notes on the video.
Yeah, and they're excellent excursion reports, both.
Yeah.
Both from Spiriver and from the Russian Academy. So
You have been there.
I haven't been there.
No. So how did you get all these things?
Well, if you are a bit good on the internet, you can find stuff you really don't know. No, I didn't pay anything.
Yeah.
What?
It's
And
an
they're all-
obsession.
I think it's impossible to distinct all these things, to make any distinction visually.
Yeah,
So
okay.
all these things have to be
It is like
analyzed.
with the- yeah, it's all analyzed.
Yeah.
It came with the same stuff I presented last time on the Cabini. So
Yeah.
it was analyzed by a Russian scientific center.
Okay.
I believe it was the freshman.
And you got it all. You got it all through the internet. You got all these things over internet.
The information, the minerals are mine.
Yeah, I know, but how did you get those minerals? Where did they come from?
Oh, I have them now for 20 years, I think.
Yeah.
And they came in a box. Someone spoke to me on a show, and he was Russian, and he said he had some stuff for me if I was interested.
Oh, okay, that's a good one.
I don't even know his name, but yeah.
Wow.
Oh, we're gonna have the next talk is about that, Paul. So
Wow.
I actually got them for nothing. So
All the type localities. Wow.
yeah, a lot.
That's great.
Yeah.
It's very rare stuff, huh?
Yeah.
It is actually very rare stuff.
Wow. Yeah, sure.
I didn't realize that until I put together my presentation, but it's actually
Yeah,
very rare.
It's very
Yeah.
rare, yeah, sure.
Gosh.
I think I have 5 or 6 of those things, but the rest I've never heard of.
Yes.
Yeah, correct.
Yeah.
Something.
So before I got
strange-
them, neither did I. So
Of course.
something strange seems to have happened with Paul. I'm not sure exactly what.
he froze. He
Paul is
froze.
frozen. Paul is
Oh.
frozen.
Definitely right.
Cat's got him.
You are in midwinter over there.
Nice pose. He's smiling.
Hell
So
froze over.
He's lost power apparently, so
You are in
I hope you
midwinter
enjoyed
over
my
there.
talk. So
no, it was good.
How is it going?
Yes, very
How is
good,
it
Frank.
All right. Any further questions for Frank? No. On that basis, then we'll see you all again in a month's time, and we'll look forward to Paul staying with us for long enough to
Yeah.
run
Get
it.
Paul to buy some new batteries.
I think he might have to.
Run-
start of the generator, Paul.
He's not on anymore. He's already dropped off. So.
run out of current.
Oh yeah.
All right. Thank you very much,
Okay.
all. And
Thanks,
see you
Frank.
soon.
Thank
Yeah.
you.
You're welcome.
See you,
Bye-bye.
folks.
Thank you.